In this video, we're going to go over how you find the equation of a normal line or segment. So this is the formula that we're going to be focusing in on x1 minus x2 times the quantity of x minus the x of the named point plus y1 minus y2 times the quantity of y minus y of the named point is all going to be set equal to 0. So find the equation for the line through A, here we're given a point A, and perpendicular to segment AB. So I remember that a normal line segment is perpendicular. So this is my first point A. So x1 is going to be 5. y1 is going to be -7. And then x2 is going to be my second point there, it's 8. And my y2 will be 2. Now I'm going to go ahead and substitute all of that into the equation that I have with a formula. So 5 minus x2, which is 8, times x minus the x of the named point here. It says through A. So that would be 5. That's with the A point. Plus y1, it's the y from the first point, -7, minus the second y, which is 2, times y minus the y of the named point. Again, that's back to A. So minus a -7 is all going to be set equal to 0. Now I know that minus a negative means to add. So it's like a +7 instead. All right, so 5 minus 8 is -3. And now I'm going to just distribute that to this expression here. -3 times x is -3x. -3 times, and you take the sign that's right in front of it, -3 times -5 or -5, that's a +15. Now I'm going to go over to the second part where the y's are. And I know that -7 minus 2, this is -9. And I'm going to distribute it. -9 times y is -9y. -9 times +7, because remember, minus and negative means to plus, where it's positive. -9 times 7 is -63. And that's all going to be set equal to 0. Now I'm going to look for what I can combine here. And I can combine the 15 and the -63. Again, you're taking the signs that are right in front of them. 15 minus 63 is -48. All right, I'm going to bring the -3x down. So now I have -3x minus 48, or plus a negative, which is the same thing. I'm going to always bring my y to the other side. And if it says minus, I'm going to add 9y. We want our y to ultimately be on the other side of the equation. So I now have this equation here, -3x minus 48 equals 9y. I would just be bringing it on down. I want my y to be isolated or by itself. So I'm just dividing everything by 9. -3x divided by 9. I'm just going to rewrite it all over here, is -1/3. It's just simplifying that fraction. -48 divided by 9. Well, I know that that's not going to come out evenly. So I'm looking for simplifying this fraction. Well, I know that 3 goes into both of them. So if you divide the numerator and the denominator by 3, negative 48 divided by 3 is 16. 9 divided by 3 is 3. So this fraction simplifies to 16 or negative 16 over 3. And that would be the equation that is the normal line or segment. I'm going to do a second one if you need another example. All right, so I'm going to just erase everything so that we have a second example. And we'll do the one on the bottom. Again, going step by step using the formula that's given and finding the equation for the normal segment or the perpendicular segment. So the first thing I need to do is I need to identify my x's and my y's that are going to be important here. So just like the first one, we're going to use these same values. So the x1 and y1 are actually going to be the same. So x1 is still 5. Y1 is still going to be negative 7. X2 is going to come from B, so that's going to be 8. And the Y2 is its value, which is 2. The difference between the first problem and the second problem here is that we're now going to use B as our named point. So x1 minus x2 all right, x, now minus x of the named point. Here that's B, so that's going to be this one. Plus y1 minus y2, y minus the y of the named point. Here that is 2. And it's going to be set equal to 0. Now we get to the algebra. 5 minus 8 is negative 3. And we're going to distribute that. Negative 3 times x, negative 3x. Negative 3 times, and you take the sign in front of it again. So here it's a negative 8. Negative 3 times negative 8 is a positive 24 or a plus 24. Now we're going to move over to the second part here. We have negative 7 minus 2. It's negative 9. And I'm going to distribute it. Negative 9 times y is negative 9y. Negative 9 times negative 2 is going to be a plus 18. And again, that's all going to be set equal to 0. I'm going to look for what I can combine. I have a positive 24 and a positive 18. So 24 plus 18 is 42. I'm going to bring that negative 3x down. And it's a positive 42, so it's plus 42. I'm going to move this 9y over. This is minus, so I'm going to add it. So now I have the equation of negative 3x plus 42 equals 9y. Last step, I want to get rid of the 9. I want to isolate my variable, so I'm going to divide by 9. Now negative 3x over 9, just like it was before. Write it right over here, is negative 1/3 x. And 42 over 9. I know that 42 divided by 9 doesn't come out evenly. So I'm going to think again of numbers that go into both of them. 3 goes into both of these again. 42 divided by 3 is 14. And 9 divided by 3 is 3. So I'm going to leave it as that improper fraction. So plus 14 over 3 is going to equal y. And that is the equation for our normal or perpendicular line.